Bright Beauty. Every student matters.
Hello students. In this lecture we will be starting with the 6th chapter of your syllabus, and the chapter is physical and chemical changes. What do you understand by changes? Here we are talking about all the different changes that you see around yourself. For example, photosynthesis, for example, boiling of water, for example, cutting of a paper, right? All these are changes, right? Something changes into something else. Or if not something else, there is a change in their physical properties, and physical properties are properties such as shape, size, color, right? So students, there are some changes that occur around us. Some of them are physical and some of them are chemical changes, right? And we have to understand the difference between them with the help of some examples that we will be talking about in this chapter. So let us start with the first kind of changes, which will be physical changes, but let us see some examples first of all. The first example is dissolving sugar and salt in water, right? This is a change. If you dissolve sugar in water, what happens? The water becomes sweet. It tastes sweet, right? Earlier it was tasteless, but after you add sugar, it starts to taste sweet, right? And if you add salt into it, it tastes like salt, right? It becomes salty. So this is a change, right? Something is happening. But when you boil this water, when you basically evaporate the complete water, what you obtain in the pan is, you obtain sugar crystals lying underneath, right? There are sugar crystals which have settled on the surface of the container. So what does this mean? That you were able to separate the sugar out? It means that the change was reversible. If you keep a plate over the pan, you will see that the water also condenses down, right? You observe some water droplets on the covering, right, on the lid. So what does this tell you? That this is a change which is reversible and no new substance has been formed, right? And there are no changes in the properties. The water acts like itself, the sugar acts like itself. There is no change in properties of both of them, right? Water is evaporating as it should. There is no change as such seen in the chemical properties of water, right? It stays as such in both the cases. So there is no new substance formed. You have your sugar and water. Water has evaporated in steam, but there is no new product formed as such, right? The second is settling of curd. Now, can you obtain milk from curd? No, you cannot. This is not reversible, right? Or you can say irreversible change. It is an irreversible change. And you know that curd is different from milk. It is not the same. Something new has been formed. Now, curd is a new product formed, right? So this is not a physical change. I am trying to inculcate the definition of physical change to you before we actually discuss it. So here we are saying that a new substance is formed and it is irreversible. You cannot obtain milk again from the curd, right? So this is not a physical change. This is a chemical change. So I hope you understood what is the difference between chemical changes and physical changes. In physical changes, no new substances are formed. There is no change in the chemical properties of a substance, and the physical change is reversible. While chemical changes are irreversible, some new products are formed, right? So these are some basic differences. Now coming to melting of wax. You know that when a candle burns, the wax melts, right? It is melting. But is there a new substance formed? Is there a new substance formed? If wax melts, you have wax. You do not need a candle. You can simply heat the wax and you will obtain the molten wax, right? But after melting, it again freezes to obtain wax, right? If you freeze this molten wax, you will get the wax again, right? There is no new substance formed. So this is a physical change because it is reversible as well. You can freeze the wax again to obtain the solid wax. So this is an example of a physical change, right? Now stretching of a rubber band. Again, another example. What is happening? You have a rubber band, you try to stretch it. What happens? It elongates, right? Its shape somehow changes. But when you put it aside, when you remove the force that you are applying, what happens? It regains its initial shape, right? It regains its initial shape and size. So this is again a physical change because there is no new product formed and it is a reversible change. The change that you were creating with the help of your force can be reversed if you put the rubber band down, right? So this is again a physical change. Now cooking of food. For example, if you're cooking Maggi, right? Maggi is the simplest example. If you're cooking Maggi, these are basically noodles. So when you cook them, after you have cooked your Maggi, can you obtain the noodles back again? The raw noodles which were not cooked? No, you cannot. After you have cooked the Maggi, you have obtained a different new product, right? Which are the cooked noodles, right? You cannot obtain the uncooked noodles from the cooked Maggi, right? It goes same for all kinds of food. You have dough and you prepare a chapati from it, roti as you can say in Hindi. When you take the dough and you prepare the roti, can you obtain the dough back again? No, you cannot, because it is a chemical change. Here new products are formed and the change is irreversible. As you can see, you cannot obtain the ingredients back once you have cooked the food, right? So there are new substances formed and it is an irreversible reaction. So this is a chemical change. Alright. Now there is an activity to make you understand even more. First activity is cut a piece of paper in 4 square pieces. You have cut a piece of paper. This was the piece of paper initially. You have cut the piece of paper into 4, right? This being the first part, then the second, third and fourth, right? Now cut each square piece further into 4 square pieces. Now you have to cut each of this piece into 4 other pieces like A, B, C and D. If you cut 4 again, E, F, G, H, and then 4 again, I, J, K, L, and 4 again, M, N, O, P. Right? You have now 16 pieces, right? Now lay these pieces on the floor or a table so that the pieces acquire the shape of the original piece. Now you have to arrange them so that they look like the initial stage of the paper as it was this, right? You have to arrange this in this particular same arrangement, right? Obviously, you cannot join the pieces back to make the original piece. You cannot join them to make the original piece. But is there a change in the property of paper? Is there a change in the property? Can you write it with the help of a pen now? Yes, you can. Can you cut it now? Yes, you can. Right? So there is no property of the paper changed. Only you have cut it into pieces. So the shape has changed. The size has changed. But not the initial property of the paper, right? The sole properties of paper have not still changed. Even after you have cut it into 16 pieces. What does this tell you? That this is a physical change. Is any new product formed? No. You have obtained paper by cutting paper. There is nothing new formed, right? You haven't obtained anything else like water or a gas. No, nothing. You cut the paper and you obtained pieces of paper. There is nothing new formed. So this is a physical change, right? Now activity 2. Collect the chalk dust lying on the floor near the background of your classroom. Right? You have a classroom. There is a chalk dust present near the board. When you collect the chalk dust, it is in the form of particles. Right? There are a lot of particles. Now what you have to do is, you can use that dust or you can take a piece of chalk and you have to crush it. You have to make it into powder. So you will obtain this dust, right? You do not have to collect it from the floor. You can crush a piece of chalk as well. Now what you do is you add some water to it. You add some water to the chalk dust, right? what happens, then you keep it to dry. You let it dry. You obtain the chalk back again. You have to add water and you have to roll it in the form of a chalk. Surround it with the help of a paper, right? You have collected the dust, you have added water to it, you have rolled it into the shape of a chalk. Now you keep it, you can either place it in a dry place, or you have to let it dry and you will obtain the chalk back again. So what is happening? When you crushed the chalk, did you obtain anything different? No, you obtained chalk dust only. There is no different product, you obtained chalk dust. Then you added water to it again. When you let it dry, the water evaporated. Right? Earlier it was dry, but earlier it was wet. But when you let it dry, the water evaporated and now you again have the chalk dust. So this was all a physical change, right? Because again no new product is formed and the change is reversible. You can again crush the chalk and you can again form chalk from it, right? So this was another example of a physical change. Activity 3. Take some ice in a glass or plastic tumbler. You have to take some ice in a glass or plastic tumbler, right? Now take some ice. You have taken a glass, right? You have taken some ice into it. Now melt a small portion of ice by placing the tumbler in the sun. You have to place it under the sun, right? Now place the mixture in a place the tumbler in the freezing mixture. In a freezing mixture basically, right? Ice plus common salt. Does the water become solid once again? You basically have to put it in a freezer, you can say. When you put it under sun, the ice melts to form water, right? So there is no ice left as such. It becomes water. So you obtained water from ice. This is the solid form of water and this is the liquid form of water, right? You obtained the different form. But when you put it into the freezer, what happens is the water then froze to form ice, right? So you obtained ice back again from water. So this was again a physical change. There is no new product formed. Ice is water as well. Water is water as well because ice is only the solid form, the frozen form of water. That's it. So physical change, basically what happens during a physical change? No new products are formed and the change is reversible. You can again obtain water from the ice, right? So this is the beauty of physical change, that it can be reversed and there are new products formed, right? Now activity 4. You have to take a container, right? For example, this is a pan and you have to put some water into it, right? Now you have to heat it, right? You have a stove and you are heating it. When you heat it, the water starts to boil, right? It's boiling. So what is happening? The water is getting converted into steam, which is again the gaseous form of water. Gaseous form of water, right? And this is the liquid form of water itself. Now what is happening? The water is evaporating in the form of steam. But if you put a plate on the container, if you cover it with the help of a plate, the vapors will only reach up to here, up to the top of the plate, bottom of the plate. So when you remove the lid, what you see is that on the inner surface of the plate, there are water droplets, right? On the plate, on the bottom, there are water droplets. So this water, where did this come from? The steam that was being formed and it was touching the plate was initially cold, right? Plate was cold. So what happened exactly? The steam rised above and got condensed on touching the plate because the plate was cold. So this water is the condensed form of steam. So the steam that you obtained again got converted to water because of the plate, right? It got condensed. So this is what I am talking about. Again, this is a physical change because you obtained the initial product simply, right? There was no new product formed. There was water only in gaseous and in liquid form. So the droplets of water are present there because of the condensation of steam that was being produced on evaporating the water, right? So in the activity you have said to put an inverted pan. You can use a plate as well. Whatever, you just have to cover the pan with the help of something, right? So this is again an example of physical change. Now, next activity. You have to hold a hacksaw blade with the help of a pair of tongs. This is the hacksaw blade. You have to, this part, you have to hold it with the help of a tong, right? Hold it from here with the help of a tong. Now keep the tip of the free end on the flame of a gas stove. You have to put a gas stove here, right? So that this is the flame and the gas stove is heating this part, right? Now does the color of the hacksaw changes? You have to keep it for at least 5 to 10 minutes on the flame. You will see that the tip of the blade becomes red hot. Right, the iron that was present on the tip of the hacksaw, it becomes red hot, and what happens then? You see a color change. Right, you are watching a color change. Now you have to remove the hacksaw from the flame. You have to make sure that the hacksaw is not present on the flame anymore. So what do you observe? That the color of the hacksaw will change back to the normal color, right? It will obtain the normal color again. It reverts to the normal color when you remove the stove. So what happened? There was only a color change, and this is a physical change. Alright. So students, let us come to the definition finally. The properties such as shape, size, color, and the state of a substance are called its physical properties. Now let us discuss the examples. In the case of rubber band, you were changing its shape and it was gaining back its original shape when you release the force, right? Now size, it is about paper, the paper activity, right? The color, with the hacksaw activity where we heated the hacksaw and it became red, and after we removed it from the stove, it came back to the normal color, right? Now state of the substance is related to ice, water, and steam activities, right? Because all these three are the states of a substance, which is water. Ice is the frozen state, water is the liquid state, and steam is the gaseous state. So these all activities indicated that these are the physical properties. A change in which a substance undergoes a change in its physical properties is called a physical change. A change in which a substance is undergoing only a change in physical properties, not any chemical properties. We will be discussing what chemical properties are. But if there is a change in physical properties only, then it is a physical change. Alright? A physical change is generally reversible. As I told you, it is generally reversible. In such a change, no new substance is formed. So what did we learn? There has to be a change in physical properties only. Right? It has to be reversible in most cases. Then thirdly, no new substances should be formed. So these are the conditions required for a change to be a physical change, right? So in this lecture, we basically introduced the topic of physical and chemical changes. We did many activities, we learnt about many changes which are physical, and we learnt that the change in physical properties, the changes in which there is a change in physical properties of a substance are particularly known as physical changes, and in such changes there is no new product is formed and the change is generally reversible. So these were the physical changes, and this was the first topic of your chapter. Thank you for your attention, students.